Assalamu alaikum students, welcome to Chemistry World. Hope you are enjoying learning chemistry. Today we are discussing about a new topic that is known as hybridization. Now, first of all, we will look at some atoms, that is beryllium. Beryllium is such an atom having atomic number 4. If you look at its electronic configuration, it will be 1s1, 1s2 and 2s2. अगर इस पे आप गौर करें तो you will come to know that it will be an inert substance. It will be an inert atom which must not react with some other atom as its outermost shell is complete. But it is not the case. It is reactive, it forms bonds with the other elements. And why is it so? That is somehow due to hybridization. Now, we move towards another atom, that is boron. Boron has an atomic number of 5. If we look at its electronic configuration, it comes out to be 1s2, 2s2 and 2px1. So according to this configuration, we come to know that it must have an electronic configuration of 1. But in actual, this is not the case. Similarly, if you look at carbon, carbon is an atom having atomic number 6, whereas its electronic configuration is 1s2, 2s2, 2px1 and 2py1. From this, we come to know that it may have an electronic configuration of 2 or 3, but it's not the case. Carbon always forms 4 bonds in its compounds. So why is it so that they have approximately complete duplets or have partially filled the outermost shell, but the valency is comparatively different from the actual, which we come to know through the electronic configuration of these atoms? So first explanation regarding this, that why is this valency different, was put it forward by Pauling and Slaughter. Now what did Pauling and Slaughter said? Pauling and Slaughter said that there are pure s and p orbitals which combine to form new orbitals of same energy. Are you getting? Okay, now how they are of same energy we will discuss it later. For now, what did they say? Basically this process is of the overlapping, basically this is the overlapping of atomic orbitals. How did they overlap? We will discuss it a bit later in this video. Now, actually this phenomena is the phenomena which just happens just before bonding. Before the atomic orbital gets hybridized, they are simple atomic orbitals, simply s and p, which just combine to yield some other orbitals having same energies. So we can say that it is a phenomena in which just happened before the process of bonding, before the bonding starts. Okay, is it clear? So these orbitals just appear at the time of the bonding. So we can say that bonding. Okay, whereas this hybridization or this overlapping is not observed in the free atoms. This phenomena cannot be observed in the free atoms. So from all this we can say that hybridization is a phenomena in which atomic orbitals of different energies how they are different in energies? That we know that S is a lower orbital, a smallish subshell lower orbital, so it has a lower energy there. Similarly, if we look at P, it has some higher energy. So different energies, orbitals of the different energies S and P just combine to form new orbitals. Of same energies, or we can say that they just combine to form degenerate orbitals. Now, what this word degenerate means? This word degenerate means that all the orbitals have the same energy. Whenever all the orbitals, atomic orbitals having different energies combine, they form degenerate orbitals. These degenerate orbitals that are orbitals of the same energies are known as hybrid orbitals. What are they called? They are called hybrid orbitals. Hybrid orbitals are basically orbitals or degenerate orbitals which are formed by mixing of atomic orbitals. So, in this process, the electron belonging to the ground state structure are promoted to the excited state, as a result of which there is an increase in the number of the unpaired electron. So here comes the reason why is these elements showing some higher level of the valencies, higher valency, which is not cleared by their electronic configuration. What actually happens? Actually, these atoms are in their ground state. In their excited state, the electron, in their hybridized state, an electron moves from their lower energy level to some higher energy level. Suppose that it has Pz. An electron from s orbital promotes towards the Pz orbital, increasing the number of the unpaired electrons, that is 4, and hence the carbon shows a valency of 4. That's why approximately all atoms which we can see in the periodic table show a valency which is not clearly defined by the electronic configuration of that particular atom. So now there must be some energy changes whenever an electron is excited to much higher energy levels. There are some energy changes, so we can say that the electron is excited. Now, how it is compensated? This is the major question which arises over here, that how the energy is compensated during this process, as the electron is excited from the lower energy level to the higher energy level. As we have studied in the Bohr atomic model, it must come to its lower energy state or stabilize itself. But how did this excited energy is compensated? This energy is compensated during the bond making process. As we know that bond making process is a stabilizing process in which whenever two elements are forming a bond, whenever two atoms are forming a bond, the energy is released, which is compensated which is a major compensation for the excitation energy, which we have seen in the whenever the electron jumps from the lower energy level to the higher energy level. Okay, now if we move forward, there are various types of hybridization. So the types of the hybridization are sp3, sp2 and sp. So how these hybridized states are formed or degenerate energy orbitals are formed, we will discuss it later in the next video. So up till now we have studied about hybridization. What was hybridization? Hybridization was a phenomena in which different atomic orbitals combine to form new orbitals of same energy. And these degenerate orbitals having same energies, are known as hybrid orbitals. And this is the major reason behind why the different atoms show greater number of valency, which is not shown by their electronic configuration. So, thanks for watching the video. Hope you have enjoyed this topic and understood each and every point of this. If you have any question regarding this topic, you can just write in the comment section. I will make sure to clarify all the confusion in this topic. And regard what are the types of hybridization, for that you must watch the next video. Thank you. Love, and do subscribe and like our channel.